Scroll through social media, and you will eventually hit a biohacker promising that with the right supplements, cold plunges, and intermittent fasting, humans can routinely live to 120 or even 150 years old. To understand why that number is so statistically unlikely, we have to look back at our historical baseline. Around the time of Christ, the average human life expectancy at birth was roughly 30 years old. This is a chart showing average global life expectancy over the last 2 millennia. For centuries, the line stays completely flat. Then, in the 20th century, it spikes upward to around 80 years. But this massive jump is a statistical illusion. We didn't actually stretch the maximum age a human body can reach. Instead, modern medicine and sanitation drastically reduced infant mortality, the death of children under 1 year of age, and early childhood infectious diseases. Medical science hasn't upgraded the basic hardware of the human machine. We've simply created a world safe enough for a much larger percentage of the population to survive long enough to experience the body's natural expiration date. Demographers and biologists who study human longevity point to a mathematical reality. If you remove all unnatural causes of death, like accidents and preventable diseases, the average maximum lifespan for the human species hits a biological ceiling right around 90 years old. There are, of course, extreme statistical outliers. This is Jeanne Calment, a French woman holding the record for the longest verified human lifespan in history, passing away at the age of 122. And this is Jiro Wayman Kimura, who represents the extreme outer edge of male longevity. He lived to be 116. These are the absolute, verified limits of human survival recorded so far. While a handful of individuals occasionally push past 110, the extreme rarity of these cases proves the rule. Statistical probability dictates a biological wall that behavioral and lifestyle interventions alone cannot breach. At the cellular level, aging is the process of accumulating damage. Operating the human body produces a byproduct of microscopic wear and tear on cells, tissues, and organ systems over time. Our bodies repair this damage through cell division. Old cells die and new ones replace them. You can think of this process like making a copy of an old cassette tape. Every time a cell replicates, there is a slight degradation in the fidelity of the original biological information. After enough copies, the signal gets fuzzy. In the 1960s, the scientist pictured here, Leonard Hayflick, made a critical discovery. He found what is now called the Hayflick limit, a biological rule stating that normal human cells can only divide approximately 50 times before they permanently stop replicating. Once a cell reaches that 50 division limit, it undergoes apoptosis. Apoptosis is a programmed cellular suicide, where the old cell systematically dismantles itself. You actually want this to happen. If cells kept replicating past their limit, your body would be running on heavily corrupted, degraded copies that could easily turn cancerous. Cellular death acts as a programmed biological safeguard that ultimately enforces a hard stop on our physical longevity. The physical mechanism tracking this cellular countdown is the telomere.
Telomeres are protective caps on the ends of your DNA strands, similar to the plastic tips on shoelaces, that physically shorten with every single cellular division. This is a scatter plot charting the rate at which telomeres shorten against the maximum lifespan of various animal species. The clear downward trend shows a tight inverse correlation. The faster a species burns through its telomeres, the shorter its maximum lifespan. It is a highly accurate predictor of how long an animal can survive. To understand why our telomere clock is set where it is, we have to look at evolutionary biology. Evolution optimized the human body to survive only long enough to successfully reproduce and raise offspring to independence. Once those genes are passed on, evolutionary pressure drops to zero. Because of this, the scissile structures we rely on, our joints, our muscle mass, and the non-replicating neurons in our brains, were never biologically engineered to maintain their integrity for 8 or 9 decades. Today, humans are walking around in bodies operating decades past their evolutionary warranty. Our success in saving people from early death is exactly what exposes us to the high modern rates of neurodegeneration and structural failure we see in late life. This reveals a flaw in our standard medical approach. We successfully extend total lifespan, but we often cause an expansion of morbidity. Morbidity is the state of being burdened by chronic disease or disability. By simply keeping the body alive longer, we keep people sick, frail, and suffering for decades. Look at this chart comparing two lifespan outcomes. The top bar shows a prolonged lifespan with a massive 20-year block of disease at the end. The bottom bar shows an alternative scientific goal, the compression of morbidity. Here, the period of severe end-of-life illness is squeezed into the absolute shortest possible time frame, maximizing the healthy years. Recent laboratory studies on aging models show that if you stretch that timeline out to an extreme, say 150 years, without prioritizing health span, it doesn't automatically compress the morbidity. It often just proportionately stretches out the final sick phase, resulting in 50 years of suffering. Chasing a 150-year lifespan is a dangerous distraction if the extra 50 years are guaranteed to be spent in physical frailty and cognitive decline. Instead, the focus of healthy aging is on maximizing intrinsic capacity. Intrinsic capacity is the total combination of physical mobility and mental acuity an individual can draw upon at any given age. You can preserve this capacity through specific behavioral interventions. Consistent daily movement, avoiding toxins like cigarette smoke, and maintaining deep social connections all serve to protect your physical and mental reserves. While these lifestyle choices won't alter our internal biological clock of aging, they drastically lower the risk of specific debilitating diseases, like heart disease and Alzheimer's, that would otherwise rob us of our final years. Human health succeeds when we reach our natural finish line with the vitality, mobility, and mind of someone decades younger.